Now let's look at the negative exponent rule. Looking at this example, we see that 3 to the 4th power is over 3 to the 6th power. So we can easily simplify this by knowing that all of the 3's cancel out on top with 4 3's on the bottom, giving us our simplified expression. But we also know we could have used the quotient rule by subtracting the exponents like so. Which leaves us with a negative exponent. So this must mean that 1 over 3 squared is the same as 3 to the negative 2nd power. Another example. Here we see that there are 5 x's on top and 9 x's on bottom. So all the x's on the top cancel out and we are left with 4 x's on the bottom, giving us our simplified expression. Again, using the quotient rule, we subtract exponents, leaving us with a negative exponent. So this must mean that x to the negative 4th power is the same as 1 over x to the 4th power. This leads us to the negative exponent rule, which just means that any negative exponent can be written with positive exponents like so. Now let's do some more examples with negative exponents. In this example, we see that there are negative exponents on the numerator and denominator. So let's rewrite this in an easier looking way. Then remember what negative exponents really mean with positive exponents. And here we see we are just dividing fractions, so we rewrite as multiplication. And done. Now we look at the zero exponent rule. Here we see that we have the same number on top as we do on the bottom, which we know is equal to 1. But recall, since this is a quotient with the same bases, we can subtract the exponents, and this leaves us with a 0 as an exponent. So this must mean that anything to the 0 power has to be equal to 1. Looking at another example. So the zero exponent rule is just knowing that anything raised to the 0 power is equal to 1. Here are some try these problems. Now let's go over scientific notation. Before that though, let's review what powers of 10 look like. The pattern here is that for powers of 10, the power matches the number of zeros in that number. We can also look at negative powers of 10, which is a similar pattern. Scientific notation is always written as a multiplication of a power of 10, as we see with these examples. Here, we are just multiplying it out, converting to decimal notation. Notice that whenever multiplying by a positive power of 10, the decimal moves to the right by whatever the power is. In these two examples, since the power was 6, the decimal moved 6 places to the right. In this example, since the power of 10 is 11, we move the decimal 11 places to the right. The next example, we notice the power of 10 is negative, so it should make sense that instead of moving the decimal to the right, we move it to the left instead. The next two examples are similar. Now let's look at converting from decimal notation to scientific notation. Here, we are just going backwards from the previous examples. We want to write the number as a product of a power of 10. Notice when writing in scientific notation, we always write the number in front of the power of 10 as a decimal. In fact, we always write it as a ones digit followed by a decimal part. Here are some problems to try involving converting to scientific notation. Here are some problems to try involving converting from scientific notation to decimal notation.